Thank you so very much for being here. Appreciate it. So when I came up with this talk, it was like, I'm looking for something fun and interesting, at least to me, to talk about. And in particular, what I want to talk about today is about Python data model and magic methods. So we'll be going on length about it. But then I thought we can probably mix up the two things I like, as in Python and magic gathering. So this is my talk. Hope you like it. In the end, you let me know. A bit of myself. I'm Valerio. I'm researcher data scientist. Been working at university before. Now I'm actually developer advocate in Anaconda and SSI fellow. But I'm also, as you might expect, Python geek. I'm in organizing different events. PyCon Italy is one of it. There's also USciPy. Casual Magic the Gathering player. Thank you. I do have my decks with me, so if you want to play. I have a couple of questions beforehand, just to get to know you a little bit. So by show of hands, how many of you think work with data on a regular basis? Brilliant. Thank you so much. That was more than I expected. How many of you use object-oriented programming on a regular basis? Well, everyone. Good. So you're probably in the wrong room. No kidding. How many of you actually work with data using object-oriented programming? Sort of, yeah. Is it like, yeah, maybe? So yes, exactly what I want to talk about. Because in data science, we say object-oriented programming is not for data science. Change my mind. What I want to do with this talk is actually changing your mind about that. And I want to start by thinking that data science is all about data, isn't it? When we have to work with data, we have a problem to solve, we can all agree that, in the end, data is way, way more important than models. So lots of time is spent in cleaning data, preparing data, having data in the right shape, and in doing what we hope we want them to do. But on the other hand, we have object-oriented programming, and indeed, OOP is all about data, abstractions, but still data. So the very core of object-oriented programming is shifting, the way I see it, is shifting completely the perspective from talking and reasoning about the behavior about something, so the actual algorithm from procedural programming, into thinking about data structures. So the focus there is no more about how you solve a problem, it's more about how you handle the data and how you make the data available to different other data structures. So it's more about data structure itself. So this is object-oriented programming. And, well, Python is, of course, fantastic because Python is supporting many programming styles, including functional programming without enforcing any. And this is a sort of a segue and a shameful plug of a talk I did at PyCon US this year, which was Pythonic functional ether tools. So that talk was actually focusing more about the functional aspects of Python. This talk is actually talking more about object-oriented programming. And in fact, we want to put the focus on that in this talk. So let's start with a Python object data model. In Python, objects are abstractions for data. And in particular, everything in Python is represented by objects and relationship between objects. So the concept of objects and data in Python can be used interchangeably. If we having a function taking another function as an object, as a parameter, that's indeed an object taking another object. Objects in Python have an immutable identity. So we have the ID function that returns an integer representing this object identity. By the way, in C Python, this ID represents the memory location of the object. The is operator works on object identities. So normally, it's good practice, Pythonic way to check whether an instance is none, meaning rather than equal to none, meaning that you're actually checking if an object is the same object as the none object. Every object has a type. And the type is what determines the operations supported by this object. So in other words, in OP terminology, we talk about methods. So when you have an object, you have some status, and the status is represented by, you all know this, of course, is represented by the value of the different attributes, and the methods is what defines the behavior of this data structure. And finally, there's the value. So every object has a value, and the concept of value in Python objects is related to another very crucial and important concept in Python data modeling, which is mutability versus immutability. The concept itself is more subtle than you think, as in when you think about containers, right? It's all about whether you instantiate an object, the value of the attributes stays the same. So it's not possible to change these values. This is what immutability means. And of course, we all know that difference between lists and tuples. They're the more famous and popular, largely used containers in Python that are essentially representative for the two categories. We have mutability versus immutability. And this is all the basic of Python data modeling, but there's also some extra things, and this is all what I want to talk about. Python magic methods, also known as dunder. What we can do with that. So before going into details, how familiar are you with the dunder methods? Pretty familiar? Would you say you use it on a regular basis? Kinda, good. So if we have a class like that, so we are defining our own class called dataset, and we also define the dunderlen method. We are essentially saying that here we can call it, we instantiate a class, and then we can use the len built-in function on this instance because of the dunderlen method. So this essentially, this method here, the dunderlen, is enabling the possibility to interact with instances in a very Pythonic way. Magic methods are just one example, the dunderlen in particular, but the whole Python data model is indeed extensive enough so that you can emulate different data types. In particular, you can emulate container types. So for example, you can work with dunderlen, but also getItem, setItem, iter, and contains. The return types are particularly interesting. Especially, well, getItem and is what you implement when you want to have a subscriptable container. So something like instance of I is an example. Like you want to access elements by index, but not necessarily like that. Even when you have a dictionary as a mapping object, you want to have a getItem to access elements by key. It's exactly the same method is called underneath. The item method is particularly interesting because it has to return an iterator over the container. And so this is particularly crucial. You normally don't want to have, and it's called by an iterator over a container. So you don't want to return an iterable, you want to return an iterator. I hope that the difference is clear, but if it's not, well, the talk about functional programming was all length about it. You can emulate a callable type. So you can make an object callable using flickering. Not using flickering. It is flickering again. Should be getting there. Oh, thank you. Please stay there. Really want me. God, yeah. So I shall look at it probably. If I look at you, you probably appear. If I don't,
it's the opposite. If you look it.
All right. Okay. Then look at that. It is. Right. Let's try to make it reasonably acceptable. So you can have a callable object, yeah, and something you can do, for example, is you'll find out in a second. Is doing a class like that. So you can have a model that is callable, and that is not, so going back to the previous example, you can instantiate a data set, you can create a model, and you can call an instance over the data set instance. It should appear at some point. Let me try to use this one. Sorry about that. Otherwise, I turn my laptop and we do it in a different way. Sorry about the technicalities here. Right, good. So that's what you can do. So you can call an instance rather than just a class. You can emulate a numeric type, and you have all this list of some of those. There's not the full list of operations you can do. But what if you can either, for example, implement a data add like this? I switched to the adapter. Probably that was the key. I have no idea what's going on.
That would be the resolution.
Reduce the resolution?
Reduce the resolution.
OK. Oh, well, if it happens again, I will do that.
Thanks, but you're trying to sort it out.
No worries, no worries. That's very okay. So this is, again, the dataset class. And what I've been doing here is like, I'm not emulating a numeric type. I'm actually implementing the add operation here. And so what I'm doing here is returning a new instance of dataset. Let me do that. Good. Main display. Let's try to mirror things. So it should be probably go optimize for this one and refresh rate promotion. Right. Let's give it a go. Good. Right. So I'm actually adding and returning a new data set which has samples, which is the sum of the two iterables there. Good. Sorry, I had to check. Now I have paranoia thing. Right. So this is the whole introduction of the topic. Let's talk about a little bit about the data challenges and let me introduce very quickly Magic the Gathering. You have to bear with me with the timing now because I can't see the time now. So for those of you not knowing, Magic the Gathering is a collectible card game that combines strategy. Oh, this is ChatGPT, by the way. I asked ChatGPT, can you summarize me for me, please, Magic the Gathering? I mean, I can't bother to do it for my own. That combines strategy, fantasy, and skill. It was created by mathematician Richard Garfield and first published in 1993. So now we're 2023, so you can essentially imagine the span of this game. In the game, players take on the role of powerful wizards using decks of cards representing spells, creatures, artifacts, and more. To defeat their opponents through tactical gameplay and resource management, players aim to reduce their opponent's life total to 0 while protecting their own. With a vast and constantly expanding universe, Magic offers a wide variety of gameplay formats, competitive tournaments, and thriving community of players worldwide. That's it. So that's Magic in short. What about the data of Magic? Well, this is how a Magic the Gathering card looks like. You have front and back. And in every single card, you have a card name, you have mana cost, you have a card art, you have edition, you have context, and you have card type. And you also have artist. So you have the artist representing the card art. The same card can come in different arts, actually. So this is the same card from different editions, and so you have different arts there. But also the 5 main colors in the game, so you have cards from different colors. So I chose some of the very famous ones. Thank you, white, blue, black, red, and green. The interesting bit about all that is it does exist a website. It's called Scrapple.com. Scrapple.com is a powerful resource for Magic the Gathering. It's indeed an engine, a search engine for Magic the Gathering. And you can, and has its own domain-specific language. You can do something like, select me all the cards which are legal in this format, and they have the frame, the all frame, because you have a new and old frame, and this is what you get out of it. So you can do your own query in this database using DSL on Scrapple. But more importantly, Scrapple offers an API to get the data. So there's a JSON, essentially data coming back if you ask for it. And in particular, the card object is kind of a complex object. So this is an example of a request you can get from Scrapple. So it's a very long and complex and nested JSON data. So what you can do is essentially getting this data and work with this data. So imagine someone like myself wanting to process this JSON data, whatever they mean. So incidentally, they're metadata gathering data, but they're just nested data in JSON format. Normally, we can go and get the JSON data and implement some sort of parsers. My suggestion to cope with this kind of problem is instead thinking of the data abstractions you need, and then represent all the data you gather from the stream of data, represent them in data abstraction, so that your code to handle the data later on in the data science pipeline will be either more Pythonic on one hand, but on the other hand, will be way easier to handle. And let me give you an example for that. So first off, considering the JSON data we had before, we can start defining some data abstractions. And so this is an opportunity for me to introduce a little bit of other nuances that Python standard library provides. As you might have noticed, I'm just using Python standard library. I'm not using any fancy library or third-party libraries. Nothing wrong with it, just saying that Python is giving you already plenty of things you can work with. First off, I have an image tuple in the beginning. So I want to define, we have this card imagery object in the JSON, having these fields, border, crop, uncrop, large, normal, small. We want to define them by name, so I want an image tuple. I can define a new enumeration there, the colors, in particular white, blue, black, red, and green in Magic, and also have the data class representing a single card. And we have everything here, and the two objects were essentially connected. So what I wanted to say there is like you can have Magic. There you go. You have, you can use colors and card imagery into the data types. Yes, something else you can do is you can define a MTG dataset. This is a genuine PyTorch dataset. It's like an excerpt of a bigger code, but essentially what this is doing is reusing the same abstractions I was mentioning before in the beginning, so that you can use a get item and a len, so that dataset is indeed represented by a container you can subscribe, so because you want item by index. But incidentally, this is particularly interesting because it's using this thing like you want an item by index. If this class doesn't exist, you can download it, you can get the image. So what this is doing is essentially returning two things. So it's giving you the card art and the set code of these cards. So and it is doing this by essentially reusing the abstractions. So if you can, this code is apart from all the boilerplate, as in if the image does exist, take it from the file system, otherwise get it, save it, and open it. That's it. But in addition to that, the label in this particular data set is returned by set code, which is an attribute from the card object. And this card object is essentially part of the initialization here, because we do have a Scrapple database, which is an abstraction over the full database, which has a method to retrieve a card here. You will find a link to the full code at the end of my presentation. But long story short here is like you're returning an image and an information, all using properties, thank you, properties and attributes. You're not for example, hard coding the fields of the JSON you want. You're abstracting out of it. So data here can come in any format. They can come in JSON, they can come in CSV, everything still keeps on working. This is the first take-home message. So, for example, you can instantiate a data set like that, and you can get an item here, items of 0, for example. This is calling getItem, and is plotting one image of a card. Still using abstraction. And again, this is very, very Pythonic, because the data you're handling is very separated by the raw data. So you've been sort of separated and managing the two things in two different ways. But something else you can do, for example, if you want to train a machine learning model there, what you can do is to pass in some, as it's customary in PyTorch dataset, you want to pass on some transformation function, as in a peel to tensor function. So something you can do is, instead of wanting the image out of dataset, you might want a tensor. And again, the code here doesn't change, so the business code doesn't change at all. And you're essentially getting, instead of an image, you're getting the full tensor representing the image and the same label. But what if I want to ask you, imagine you have the same set of data, but different data problem. Instead of having, so in this particular case, this is the two examples working on the sample size, if you're familiar with machine learning. So you're working on the actual data. What if we want to, that we train the model on, what if we want to change, for example, the label? In this case, we're using, imagine we want to define a machine learning model that is able to get all the images and is predicting who's the artist creating that card art. This is an interesting problem by itself, because every single artist has its own way to design card arts. The only thing you had to change in all of this implementation was essentially this one. This line here is the label is different. You can abstract that by making, I don't know, a property. That would be way better. So, sorry, that was the very last line. But essentially is, you can define a property as a label, and you can say which is the attribute from the abstraction you want to take away from it, and it's not changing anything. You can just subclassing your MTG dataset for your own specific thing, and everything still works. And you're not hard coding anything but the way you do handle your data abstractions. So the takeaway message in all of it is Python data model is really cool because you can work with it in a very Pythonic way. And the way in which you should use it, in my opinion, the Python data model is by using proper data abstractions. Because it makes your pipeline very easy and maintainable in the end. I think the last thing I wanted to show you, in the interest of time, I think I have very few minutes, right? OK, so I will be taking some time for the questions to show you this, this sort of live demo. I'm crazy to show you live demos. But it's also an opportunity for me to introduce PyScript. Do you know, has any of you known about PyScript so far? Brilliant. So I will be showing an example of PyScript. For those of you not knowing, PyScript is a Python running in the browser. So let's see if I'm lucky enough to have it working. I'm relying on internet, so right. So essentially what this is doing is, well, this is an HTML page. And I need to see the tabs. Probably full screen is not helping. One thing you can do is, like, for example, you can go to any website here, Magic Gathering, and you can get a deck list, as in this one. Let me just get any of that, right? So getting this deck list, this is the list of cards in this deck. I want to copy and paste them into this one, and then cards have been automatically recognized. So something like internet is not working really. Thank you, timeout. So why is this interesting? So we can view the code in PyScript.com. Essentially, what I'm doing here is, interestingly enough, let me just skip to the bits which is particularly useful to talk about. You can essentially, if you want to play with this, you can copy your own project in Python.com and you make your own or just run it. The link will be in the slides. But the core thing is in the data, the data module. We have the same abstraction we've been using before. The Scrapple database is here, so this is all to have this method returning data from the database using cards object. So this is essentially the middleware class you need in your pipeline that transforms data from raw format into these abstractions. In this particular case, it's called Scrapple database. And the last bit I wanted to show you here, I can't have the time. I can't explain everything in details. I'm afraid, but I'm very happy to take it offline if you're interested in how this PyScript thingy works. It's interesting that when you have parser, parser is interesting. When you're processing a deck, you can essentially rely on the fact that you're having this is a data app rather than a data science app. So the reason why I'm showing you this is that the same sort of lessons can be taken away even if you're not essentially putting up a machine learning pipeline. As in, if you work with your abstractions in a way which is reliable and maintainable throughout the different processing and manipulating of data you have, this all stays in place and is still very Pythonic. In this deck is essentially I'm using these abstractions to gather information from cards. And so like a deck is a collection, is indeed a container, a collection of cards. And so you keep on having this hierarchy of objects, all very Pythonic and all very easy to work with. So that's all I have. Thank you very much. That's it. Apologies for the technical difficulties here.
Okay, so there is any question in the room? Okay, no? Okay.
Any questions at all? Do you want me to show you more in the... We have a couple of minutes if you want. Anything yeah?
Sorry, I'm just curious if you if you've used Pydantic for
Yes,
validation.
I was sort of expecting that. Pydantic is a brilliant project. I certainly recommend it. I haven't used it specifically because I wanted to, stay on the standard library side. But Pydantic is certainly the next step. So for those of you who don't know, do you all know Pydantic? So essentially, Pydantic is a brilliant project which is based on the same sort of assumptions. As in, you want to have your data abstracted, and you want to have a method that ensures that the abstractions is consistent throughout the APIs. Is that a good way to put it? So that's what Pydantic does, and this is very particularly useful when you're working with unstructured data like JSON. So you're making sure that your pipeline is essentially passing through the same kind of objects. Yes, absolutely. It's the next step, essentially. So when you want to sanitize your data science pipeline, Pydantic is the way, I'd say.
Okay, we have time from the very last question.
If any. Otherwise, thank you so much.